Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Hi guys, it's Madam Mariam again. Today we'll go into chapter 5.5, which is diffraction by a single slit. Now, diffraction is pretty similar to interference, so I want you to recall back what we have learned about interference, which is caused by interference of two light waves, where they put either two double slits or the light goes through different medium or thin film or other methods such as Newton's ring and so on. Right? So what is similar between these two is diffraction also happens by wave of light that passes through a slit, but it's either a single slit or more than two slits or multiple slit diffraction. Okay, so how does this happen? Okay, according to Fresnel's wavelet theory, when he placed a solid disc in front of a source of light, what happened is these two wavelets here, okay, they will interfere with each other and causes a bright light in the middle of the shadow produced by the solid disc. So this effect actually proves that light has a wave property. So how does this experiment is conducted? Okay, instead of a Young's double slit use two slits. So instead of two slits, they use only one slit. Okay, of course we need a source of light. Right, so this light will pass through the slit itself, and it will create an diffraction pattern on the screen. Okay, but the only difference is for diffraction, the central maximum, or where the light hits, okay, it will have the brightest fringe. Okay, same thing, it will produce fringes, but the only difference is the center bright fringe would be the brightest and the biggest in size. Okay, and then it will be accompanied by what we call a secondary maxima or a side maxima, or also secondary minima. This is similar to constructive interference and destructive interference, but the only difference is we don't call them interference, we call them maxima or minima. Right, so beside the center bright fringe, which will have the brightest and also the biggest in size, okay, we will have the secondary maxima, okay, which is half the size of the center maxima. So this is the secondary maxima. This will be the center maxima. Okay, so where does the minima produce? Okay, minima is where there will be no light produced. So we call this minima or secondary minima and so on. Okay, I'll go through that more later on. Okay, so this is how it looks like in real life. This is an example of a diffraction pattern. As you can see here, the center has double the size of the other fringes. Same for the dark fringes, also they would have the same size of the secondary maxima. Okay, same thing here, secondary minima would have the same size as the secondary maxima, and this pattern would continue on and on. Okay. Or this is another example. The diffraction pattern consists of central maximum, okay, we call it central maximum, and a series of secondary maxima and minima, which is also similar to interference pattern. Alright, now how does this happen? Let's look at A first. Now if you shine the light straight towards the slit, you can only see a central bright spot because all the rays are in phase. Rays of light are in phase, or the wave of light are all in phase. Okay, but if we move it at a certain angle theta, okay, so let's say we shone the light at a certain angle of theta, okay, the top slit or the topmost slit here would travel an extra distance of lambda as compared to the one below it. So when it travels at a distance of lambda, again we can use trigonometry, okay, to find sine theta. Okay, let's say this is our theta. Alright, so because I want to use this value and also this value, I forgot to tell you, okay, for interference, the distance between the two slits is called D. But for diffraction, we don't call it D. we only use the size of the slit, or we write it as A, which is the diameter of slit. Okay, so that's the difference between interference and diffraction. So, like I mentioned just now, I want to find sine theta. So let's say this is my theta. Okay, so if sine, you will get sine theta is equivalent to lambda over A. Okay, this is actually your equation for diffraction. We call this maxima we call this destructive diffraction or destructive interference equation, which is, if we simplify them, it will become sine theta is equal to lambda over A. So lambda is equal to A sine theta. Okay, we'll look at this later on. Right. So the next one, okay, it will travel another extra half lambda when I increase the angle of the light shown towards the slit. So when I increase the angle, okay, it will travel 3 over 2 lambda further from the bottom 3 here. So ray at the bottom third of the slit will cancel in pairs with those in the middle third. Okay, so it will cancel out here and here, but light from the top slit will still reach the screen. So from here, it will still reach the screen. So it will produce a bright spot. Okay, so see, we will get here sine theta is equal to 3 over 2 lambda. Right, so 3 over 2 lambda, okay, over A. So I'll simplify this. I will get A sine theta is equal to 3 over 2 lambda. Okay, this pattern here is important to determine the equation of diffraction. Let's look at D now. Alright, so I will increase again the angle. Again, the bottom here will cancel out this part here. Okay, and then it will cancel out this part again. And then finally here, which will produce zero intensity, or it will become destructive like this one here. Okay, so I will still get same equation of lambda is equals to A sine theta. So why do we need to know this? Right, because this will result in the pattern of light and dark stripe, which is called the diffraction pattern. Remember the diagram I showed you for interference? Okay, similar diagram to this, where you can actually determine which one is the center, which one is the first constructive interference or destructive interference. So it's the same thing. Okay, so let's look at diffraction. The only difference is, as you can see here, the intensity of light for the center maxima is the highest. Right, and then the rest would be smaller or will be lesser. Okay, alright, so now how do we know which one is your order? Right, so the center here, okay, we call it central maxima. Okay, do not take the order. Remember when we did interference, we took for constructive interference, for destructive interference, we always start with for interference, okay, for constructive interference we start with 1, but for destructive interference we start with 0. But for diffraction, always start your M with 1. Because why? The pattern here is not full, it is divided by half. So we don't consider M is equals to 0. We'll just call it central maxima. So the first order will be here, M is equals to 1. Okay, this will be your maxima, first maxima. Second order will be here. This will be your secondary maxima. Same thing here, M is equals to 1. This is M is equals to 2. So where will be your destructive interference? Here. This will be your first order minima, second order minima, third order minima. Same thing here, first order minima, second order minima, and the third order minima. Understand? Okay, I hope this is, you are still okay, you are still following me. Right now, That was the explanation on the intensity of light as well as the other. Now the center bright fringe, one more thing that you need to know, the center bright fringe maximum is twice as wide as the secondary maxima. So the distance here will always be double the size of the rest, or we write it as 2y. Okay, if that is in meter, or you can also write it in terms of angle, which is 2 theta, because sometimes they will ask you the question and want you to give the answer in theta or in angle, or they want you to give the answer in distance or in meter. Right? Okay, so these are the equations that I mentioned just now. Okay, so for minima or for dark fringes, the equation will be A sine theta is equals to m lambda. It's actually the opposite of interference. If interference, this will be the equation for constructive. But for diffraction by single slit, it will be the opposite. So the bright fringes will be A sine theta is equals to m plus half lambda. Double check again these two equations with what we did previously using these examples, and it will make more sense and you will understand it more. Alright, now remember how we calculate the distance between fringes for interference. We wrote it as x, but for diffraction, let's write the symbol as y. Okay, so the distance between the fringes will be y. So if let's say I want to find the distance from the center maxima to the first maxima, this will be my y, and so on. So the equation of y will be m lambda L over A. Also pretty similar to interference film. The only difference is the symbol. So we don't use the different distance between slit. We use A as the opening of the slit or the diameter of the slit. Again, we are going to use L, which is the distance between the screen and the slit. Of course, the lambda, the wavelength of light, and also the order.